Right, we've got a worked example here for the data section. It's on mean and variance, and this is to do with a Sudoku competition. The class of students had a Sudoku competition. Time taken for each student to complete the Sudoku was recorded to the nearest minute, and the results are summarized in the table below. Okay, so we've had 30 entrants to this. I think that's up to 30 there, and the results have been summarized in this table. I'm just thinking, well, 30 is too many individual results to handle. Let's put it into a table, and this table's, let's say, it's been passed to somebody else who hasn't got access to the original set of numbers, and this is what they're going to use in order to draw their conclusions. So let's have a look at the first thing. Right down the midpoint for the 9 to 12 interval. Somehow it got missed out. Well, all it is the average of these two, isn't it? It's the point in the middle. It's the mean of these two, I should say. So that's 9 plus 12 is 21 divided by 2 is 10.5. It's exactly what we've done with all these others. So that's the answer to part A. Use linear interpolation to estimate the median time taken by the students. Okay, so the median. So the median, we've got 30. So the median would be the middle one, but when we've got an even number, it's actually, we're looking at the mean of the 15th and the 16th. So we want, sort of conceptually, we want the 15 and a half up here. Well, 14 of them are taken account of in these first three categories. So we're kind of 1.5 into this 8 is where we're looking for our median. So the 15.5 is 1.5 eighths. So if you imagine that these 8 are evenly spread throughout this interval, then we're 1.5 eighths into this 16 to 8 period interval. That would be linear interpolation, and so therefore, given that we've got 14 already, we then have to go another 1.5 eighths through an interval which is too long, too wide. Okay, so that is our little formula, our little equation, and yeah, that's going to give us 14.375. So our estimate of the median on that basis would be 14.375. Now, these are one or two assumptions there, which perhaps not quite right. If we assume that all these things are evenly spread, all these are evenly spread throughout, then the lowest one in this group here is not going to actually sit on 16, which is sort of what we've assumed here. It's going to be a little bit higher than that. But at the end of the day, it says estimate the median time. So the assumptions that we're making, really, I mean, we can make different assumptions, we get slightly different answer. So I think for the purpose of what we're doing here, it's quite reasonable. If we wanted to be a little bit more perhaps a bit picky about our assumptions, we might say, well, it's the fact that we don't actually, none of our 8 occupy the endpoints of the interval, then it might give us a slightly different estimate. But this is a reasonable estimate, and this would get you the marks. C, estimate the mean and standard deviation of the time taken by the students. Okay. Well, in order to do this, what we need is we need the sum. We need the sum of all the Sudoku times. Well, we don't have the sum because we don't have the original data. So what we're assuming is that both of these two act at the midpoint. So they both have value 5. All these 7 have value 10.5. That's what we're assuming for this, and so on. So we can actually work out an estimate for the total number, which is going to be this sigma fx here, frequency times the actual value across all these categories. So for this category, it's 10, 73.5 for this category, that's 7 times 10.5, and so on. Add all these down, we get 477.5. So that is an estimate for the total time of the total of the times of the contestants. It also gives us something here, saves us a little bit of time, because we're going to need the sum of the squares. Okay, so this is basically this squared. Imagine we square all these and add them all up. This is what we're going to get. But again, we're assuming it's the midpoint that we've got, so we're multiplying each of the midpoints by the frequency, and that's giving us that, the sum of all the frequencies times the values x squared, where the value is, we're using the midpoint for them all. Okay, so that gives us a mean. Well, just to take the mean, we basically want to divide by the count. So we take the total number and divide by the count. That gives us a mean of 15.92. The variance, and go back to see if we can remember this, is the mean of the squares. It's the mean of the squares minus the square of the mean. Yeah. So we've got this thing here. It's given us that. We calculated this. So basically, we just kind of work that through, and that gives us a variance of 33.4514 to 4 decimal places. Okay, so basically that's it. We've got a mean of 14.375. Made a change on there. It's 14.375 and a standard deviation of 5.78. This is the variance. Of course, we take the square root to find the standard deviation. Okay, so the teacher suggested that a normal distribution could be used to model the times taken by the students to complete the Sudoku. Give a reason to support the use of a normal distribution in this case. Well, first of all, I think we'd say that the mean and the median are similar, probably similar enough. So that suggests sort of symmetry in the distribution. And also we've got 30, we've got a count of 30 participants. So that's, you know, as the count gets bigger, it's going to approximate better to a normal distribution. Okay, okay, and so what we're doing here when we use a normal distribution, I think, you know, the effect is what we're saying is, well, if we use a normal distribution, we can use this in order to predict the times for any students, you know, for future Sudoku competitions. There's one or two sort of arguable things about this, but that's essentially what it's asking, and some of the subtleties around that we'll save for a different video. So that is basically it. I hope that's been useful. See you next time.